So today we're going to talk about confidence intervals. We never really or very rarely have access to an entire population, as we've talked about, so we virtually always need to work with a smaller sample. And when you get that sample, you're going to be able to compute a sample mean, a standard deviation, and so forth. And those are going to be your best estimates of the mean, the standard deviation, etc., for the entire population. But the likelihood that the standard deviation and the mean that you come up with for your sample are going to be exactly the same as what we would find for the entire population is virtually nothing. It's going to be very, very close, but it's going to be something that's a little bit different. So the sample mean we call our point estimate of the population mean. But many times it's even more useful to be able to think in terms of what's called an interval estimate of the population mean. A range of values that, especially if our sample size is relatively large, is likely going to be very tightly packed right around that sample mean, that we can have a certain level of confidence about whether or not that range will include the true population mean. So that's what confidence intervals or interval estimates are all about. We're going to compute these interval estimates using StatCrunch, and there are three different ways that we'll have to go about it depending on what type of variable we're dealing with and sometimes how large our sample size is. If we have a quantitative variable, then we have two different options. For sample sizes that are greater than or equal to 30, we're going to be using ZStats. And if we click on our stat button here in StatCrunch, you can see that we have an option here for ZStats. A little bit more about that here in a minute. If our sample size is less than 30, then we're going to have to use the next one down, and that is TStats. And finally, for categorical or qualitative variables, we'll have to use the next option down in our menu there, and that is proportion stats. Now, fortunately, once we have come to the determination of which one of those three tests we need to use, the way that we put the information in, the way that we read the output, all works out to be pretty much identical. So we really only need to learn one process for using StatCrunch to generate these confidence intervals. We just need to be able to distinguish between which of those three options we need to use. So again, quantitative variables with a sample size greater than or equal to 30, we'll use a Z-stat, and that's based on the central limit theorem that we talked about last time, where we were able to show that regardless of what our population distribution looked like, when we have a sampling distribution of at least 30 observations in each sample, that sampling distribution is going to look like a very tightly packed normal distribution. So let's take a look at page 308, problem 6.8 in your book. It says the mean and standard deviation of a random sample of n measurements are equal to 33.9 and 3.3 respectively. So we have a mean of 33.9 and a standard deviation of 3.3. They want us to find a 95% confidence interval for the population mean if our sample mean, if our sample size is 100. Well, we have quantitative data. They're talking about a mean and a standard deviation here. So this is quantitative data. And our sample size is greater than 30, so we're going to use our z-stats. This is one sample. Later on in the book, several weeks from now, we'll get into two-sample testing, but for now, everything we're doing is a single sample. And they've just told us what the mean and the standard deviation for this sample is, so we have with summary information. If we actually had a data file that had each of the different observations of those 100 participants in the sample, then it would be with data. But if they're giving us the information, it's with summary. Once we've clicked on that, we just put in the relevant information. Our sample mean was 33.9, our standard deviation was 3.3, and our sample size was 100. And at this point, we are looking for the confidence interval at a 95% level of confidence. So all we have to do then is click compute. It gives us our results here. Shows us that the sample mean is 33.9 and standard deviation is 3.3. That was the data that we put in there. And it also shows us that the lower limit for our confidence interval, or our range, is essentially 33.25, and our upper limit is 34.55. So we can write that as our 95% confidence interval goes from 33.25 to 34.55. We round those up. Now, essentially, what that's telling us is, we did this sample of 100 observations. We got a sample mean of 33.9. That's our best estimate for what we think the population mean might be. But it's likely to be very close to that, but slightly different. This confidence interval tells us that we can be 95% assured that the true population mean is somewhere between 33.25 and 34.55. That's very, very close to the 33.9 that we came up with as our sample mean. In fact, what that actually says is, if we were to go out and take 100 different samples of 100 observations here out of this population, we would expect 95 of those 100 samples to have a mean between those two values. And the 5 that are outside that would probably be pretty darn close to those values as well. I want to take a look at one more example here, and that is problem 6.33 on page 318. This one gives us a data file, and it is the file called rpipe here in chapter 4. I'm sorry, chapter 6. That's what I need to get to. Chapter 6, rpipe. And this measured the roughness of different sections of metal pipe. And these values here represent microns that were measured as how much roughness there was on those different pipe sections. Now you'll notice there are only 20 observations here. It's definitely quantitative data, but we only have 20 observations in our sample. So we're going to use the t-stat version here. It's a single sample, and now we have with data because we have all 20 of those observations. We're going to select the roughness column, and then confidence interval for the population mean at 95%. Click compute. Again, we get similar type of output. Our sample mean, they tell us, was 1.88. That's our best guess as to what the population mean is, but we can't say for sure that the population mean would actually be 1.88 But what we can say is we're 95% certain that it's somewhere between 1.64 and 2.13. So we can narrow in on a very good estimate of what that population need